Welcome back to my channel FusyBots. In this video we will going to learn how to make a custom mobile robot URDF with a differential wheel drive controller for it. This is a continuation in mobile robot series. So let's start with the video. Starting first with the URDF. You can see on the screen is the URDF I made for my mobile robot. Basically I have defined some links. First of all, you have to define the robot name. You can define any name here. Then first is the body link. Body link is basically the main frame of the robot. Then there are 4 wheels. Mu is basically the friction coefficient. You can define any friction coefficient that is near to practical. I have defined mu that is equal to 0.2 here. You can define anything else also. So this is we are defining it for Gazebo. We are using a lib Gazebo ROS differential drive. So there is an inbuilt plugin for differential drive control for mobile robots, and there is a library available in ROS 2. So we are using that library only. So how to define this plugin? In your URDF itself, you have to define this Gazebo here. And in this Gazebo you have to first give the plugin name. So plugin name you can directly give because it is present inbuilt in ROS 2. Then we have number of wheel pairs. So we have 2 wheel pairs. Now we have 2 left joints and 2 right joints. Take care of this thing very carefully because this can create problems while doing the control of mobile robot. Make sure that these are correct. For example, left joint for me are wheel 1 and wheel 3 and right joint are wheel 2 and wheel 4. So according to this, when you will do the control, this will affect that. Then we have the wheel separation, wheel diameter, then torque, acceleration. This you can define anything. After that, the important thing is publish ODOM TF, then publish wheel TF. So ODOM basically what it does, it will basically publish the odometry information of my mobile robot on ODOM topic. From there we can get all the transformations. What you are seeing on the screen, it is a very important thing. Then next, the most important thing is the base frame, means robot base frame, and this must be a fixed frame. From this only we will define where our robot is going. All the things, like if we are saying that it is going at a position of 1,2, it will be defined with respect to my dummy frame. Starting now with the URDF, it is the same as we have done in manipulators. In manipulators, I already have one video how to define the URDF of a manipulator. In the similar manner, we can define the URDF for mobile robots. Starting with the dummy link, I already told you that dummy joint is a fixed joint. Now this is the parent link for body link. Then we have body link, that is the main frame of the robot, geometry of that, origin of that, visual collision and everything. Then we have the inertial information. Similarly, if you want to get detail about what all are these, you can go to my manipulator video where I have a special video for URDF only, like how to define URDFs, how to define frames. So here one thing you need to know that is different here in mobile robot is that the type of joint we use, it is a continuous joint because the wheels are continuously moving, and this is already defined in ROS 2, continuous joints. Again we have body link is the parent link, then wheel 1 link is the joint link. Similarly you will define wheel 1 link, then wheel 2 joint, similarly continuous, then wheel 2 link, wheel 3 joint, wheel 3 link, wheel 4 joint, then wheel 4 link. This is normal how we make a URDF, nothing fancy. The important thing is how to define its controller, differential drive controller. For this, take care of how I have defined it here. Then we can go to our launch file. I have made a minimum launch file for this. What we have to do, we have a URDF file first of all. This is my URDF file, I have to define it here. Then how to spawn the model in Gazebo. So for that, this node is required. You are seeing on the screen. So package is Gazebo ROS, spawn entity is the executable defined there. See, I am taking the topic robot entity. So What URDF is basically doing, when you are opening the URDF, all the robot state publisher will publish everything on the robot description topic, and then the Gazebo will take all the information from this robot description topic. Okay, this is on the screen you can see my robot state publisher. This robot state publisher basically takes from a robot description. So robot description topic is very important for any URDF because all the data is coming to robot description. Every node you start can take the data of all the transformations from robot description topic. Just take care of it. You can use it anywhere you want. After that we have 3 nodes. Gazebo launch, we are starting Gazebo, we are starting robot state publication, and we are then spawning the model. You can see it on the screen how it looks. Now we will go to terminal and we will launch our file. This is my launch file you are seeing on the screen. Let's launch the file. As soon as I launch my file, see what is there. Spawn status, spawn entity, successfully spawned entity. Wheel 1 separation, wheel 1 diameter, everything is there. Subscribe to command velocity, advertise on ODOM. I told you that transformations are coming on ODOM topic. So advertising on ODOM, and this is a differential drive robot. See, that is the lib ROS Gazebo we have used. Now as you see in the Gazebo, we have this model here of the mobile robot. This is a very simple mobile robot, and you are seeing we have some obstacles here. For the obstacles I have defined one file, empty world file. In this I have defined some obstacles. These are not necessary for the part we are doing right now. After that I can start my mobile DD robot node. This is my wheel control node that I have made, and a minimalistic UI, not a very fancy one. As soon as I print any value here, for example 1,2, and I will start, my robot will start moving and it will go to 1,2 position. This is how we can make our custom robot and deploy in Gazebo. Thank you for watching this video. If you have any doubt or any suggestions you want me to improve, you can just write it in the comment section. In the next videos we will also going to learn how to plan path and trajectories for mobile robot to go to different positions. So stay tuned for that. If you like the video, please hit the like button and also subscribe my channel FusyBots. Thank you. Bye bye.